Hey everybody, another type of problem in your homework from 4.1, basic probability, and this deals with the term sample space. Okay, what is the sample space if you flip a coin once? So sample space, and what we're looking at is that basic premise of the probability of some event is equal to favorable outcomes over total possible outcomes. And you need to make sure that you know this and you remember it. Total possible outcomes. All right. So to just be able to tell you what is sample space is simply the denominator. This is sample space, my total possible outcome. Sample space is like the value n. That is my sample space. All right, so for what we're looking at here for our question, it says, what is the sample space if you flip a coin once? Well, what are the outcomes whenever you flip a coin? You can either flip that coin and you get a heads or you get a tail. This is my sample space for one flip. Two outcomes. It's one or the other. Now the next one though, B, is a little bit more complicated. What is the sample space if you flip a coin three times? All right, so this is more complicated and there's two different ways to work it. Okay, so two ways to solve. And both of them involve visualizing. It's actually doing something. So the first way, I believe they call it making a tree diagram. And that's what we'll do. So for our tree diagram, what we have is we have the flip of the coin, okay? And from there, we have heads or tails. So that right there, that is going to be my first flip. And then I flip the coin again. So either one of these pathways is possible. When I flip it again, I can have the exact same thing. I can either have heads or tails. And same here, I can have heads or tails. This was my second flip. And then if I flip again, I can have heads or tails, heads or tails, heads or tails, and heads or tails. This was my third flip. So my outcomes, we'll just follow the path. So we go heads, 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 tail, heads, tail, heads, or heads, tails, 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 heads, heads, and you just repeat that pattern. So that's the first way, and these are my outcomes, or how about total outcomes. This is my sample space for what I'm looking at. Or you can do it another way, and I don't know what this is called. We'll just call it the block method, okay? Because it kind of looks blocky whenever you get done with it. What I do is I look at I pick one of them to start with, and for instance I'll start here. I'll say okay, I'll start with heads, 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 and what I'm going to do is I'm going to add in a single tail during my flips, and I rotate the position of that tail through those heads. Now I'm going to add in, and if we just look at it, see, like here was 3 H's. Here, if you notice, how many H's are in this one? 2 H's. So the next one, what do you think it's going to be? Yes, 1 H. So I'm going to start and I'll say heads, tails, tails. So tails, heads, tails, or tails, tails, heads. And each time I moved that head, uh, the H, in a different position. And the last one that I have is going to be what? Zero heads. It's only tails. And if you notice, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, and they match up. So same thing. Either method is fine to use. What it depends upon is how you see the problem and how your brain works in being able to solve that problem. So again, I want to be able to point out to you that sample space is your denominator in your basic probability ratio. It is the total possible outcomes that you deal with. We refer to it often as N. Whenever they become more complicated, this is nice. If you could just picture this in your mind and see it, excellent. But the more complicated they become, we have to write it out and then work it through. There's not just an easy mathematical way to where I say, hey, plug it into this formula and this is what you get. So please continue to watch the publisher's videos, structure, critically think about your homework, write everything out as you're working it. Good luck on your homework.